Okay, so I'm going to walk through the last 2 pages of notes here, and um, these are the last 2 pages for Unit 2. I have posted already the um, hard copy of these, the handwritten version of these, but I want to talk through a couple of places. So this is just a Word document, and I'll be typing into it here. So it starts off kind of where we left off, talking about the at least situation. So for probabilities using the phrase at least one, and then the question is one what? Well, one something. For at least one something, find the probability of 0 somethings and use the complement rule. That's what we're going to do here to make sense of this. So we've got our finished blood type data. We've seen this a couple of times before. And if you remember correctly, the finished blood type data, these are all independent of each other, because we can assume that as we grab people on the street, we don't have to worry about running into somebody who is um, both O positive and A positive, and we don't have to worry about choosing somebody on the street who is O positive and that somehow affecting the next person that we pick. So randomly selecting 2 finished people is going to be an independent situation. So these are independent events, selecting the 2. So now the question is, what can we do with that information? Where can we go with that? If we choose 2 people at random, what's the probability that at least one of them is O negative? And according to the situation above and our old friend the complement rule, the probability of at least one O negative is equal to 1 minus the probability of neither being O negative, or 0 being O negative. And that means, let me stop the underlining here, and that means I should be able to just write this is equal to 1 minus the probability of both of them not being O negative. Well, probability of one of them being O negative is 0.04, so the probability of one of them not being O negative is 0.96. So if I have 2 people that are both O negative, or excuse me, not O negative, the probability that neither is O negative, since they're independent, is 0.96 times 0.96. So the result that I have here, 1 minus 0.96 times 0.96, is 1 minus 0.9216 on a calculator, which is the same thing as 0.0784. Okay, I just rounded it off there. So it's about almost an 8% chance that if I randomly select 2 finished people, that at least one of them is going to be O negative. At least one is O negative. I use the complement rule. I can do the same thing here in part B, but to a different degree, by saying I'm going to choose 3 people this time. So what's the probability that at least one of them is O negative? Well, just like before, I can say the probability of at least one O negative person is 1 minus the probability of none of them being O negative. So if I figure this out using the same techniques as above, it's 1 times 0.96 times 0.96 times, times 0.96. Or another way we could say it is 1 minus 0.96 cubed. Okay? 1 minus 0.96 to the power 3. Okay? And you could type that into your calculator and do it that way. The result of this turns out to be 0.1153, somewhere around there. So there's about a 12% chance that at least one of them is going to be O negative. Why is it higher? Well, we're selecting more people. There's going to be more of a chance that one of them is going to be O negative. So we'll check in on example 10 and the next page in the next video.